Okay, you're asked to estimate the area under the graph of 1 over x plus 3, which this is the graph of that function, or at least a portion of it. And you're supposed to use right-hand endpoints over the interval from -2 to 1. So, and we're using 8 rectangles. There's the 8. So the width of each of these rectangles is the right-hand endpoint, which is 1, minus the left-hand endpoint. That's the distance from -2 to 1 divided by n. So we're dividing the interval from -2 to 1 into 8 subintervals, each of a length of 3/8. So this distance right here is 3/8. You could convert that to a decimal if you wanted to. And what you have to do for right-hand endpoints is realize that we're starting at -2 on the left. And to get this point right here along the x-axis, we're going to add on 1 width. So S of 1, the first right-hand endpoint, is -2 plus 1 width, which reduces to -13 eighths, -16 plus 3/8. This is a plus sign. Okay, so if we plug that number into the function, we'll get the height of that first rectangle. So here's -13/8 plugged into that function, 1 over x plus 3. That's a complex fraction, which is easily reduced by multiplying numerator and denominator of the big fraction by 8. So 8 in the numerator, 8 times -13/8 is -13. 8 times 3 is 24. So the height of this rectangle is 8/11. And to get the area of that rectangle, we multiply length times width. So 3/8 times 8/11. The 8's cancel out. The area of this rectangle is 3/11. And if we move on to the second rectangle, we're starting at -2 and adding on 2 of these widths. So -2 plus 2 times 3/8. We could reduce this to -5/4. I just happened to leave it as -10/8. Plug that number into the function, multiply numerator and denominator by 8. We get 8 times over -10 plus 24, or 8/14, which this time I reduced it to 4/7. So again, this width is 3/8. But when I plug this number right here into the function, I get 4/7. And the area of the second rectangle is 3/14. And since this is a decreasing function, we would expect each of these areas to get smaller and smaller. And you can see that they are. If you use decimals, oh, by the way, so you have to do that 8 times. Really pretty tedious. We got to find a sub 3 through a sub 8, and then we add these all together, and that will be the approximate area. You have to get a common denominator, add all the numerators together, and ouch. Here's what it looks like with decimal approximations. Again, each of these is 3/8, or, well, what is 3/8? 8 into 3, 0, 0, 0. Well, I think that's 0.375. So each of those rectangles has that width. What's this? It was that 8/11 that we had. So this number right here is actually a decimal approximation for 8/11. And the area of this first rectangle is, again, 0.7273 times 0.375. Long and tedious calculation, but that's what's involved in using Riemann sums to approximate the actual area under the curve. There you go. I hope that gave you some ideas how to proceed. If you have any questions, post a comment.